In this video, we are going to talk about the linear search and the binary search. If we have a list of numbers and we want to find the location of a target value in the list, we can use either of these two methods. Linear search is straightforward. We just need to sequentially check each element of the list for the target value until a match is found or until all the elements have been searched. So here is the code to implement the linear search. And we can see we use a for loop to check each element in the list. Now here's a question. If the list is ordered, do we still have to search it by looking at location 0, then 1, then 2, then 3? What if we looked at the middle location first? So if the value of x is greater than that value, we know that the location for x is in the upper half of the list. Otherwise, the location for x is in the lower half of the list. So this is the binary search. By making one comparison, we can eliminate half the list in our search. And we can repeat this process of halving the list until we reach just one location. Okay, so here is the algorithm of binary search. And we give an example so as to understand it better. So we have a sorted list of V, which with the elements from 0 to 6. And our target value is 1. At first, our low is 0 and our high is 6. We know our low is smaller than high, so the mid is the average of our low and high, which is 3. And since V3 is larger than x, our high equals mid minus 1, which is 2. Again, we compare low and high, and since low is still smaller than high, our mid is 1, which is the average of low and new high. So now we can see at this point, our low is 0, high is 2, and mid is 1. So since V1 equals x, we've successfully found the location of x in this list. So we return mid. Now we've learned two different search methods, and we can analyze them by their complexity. So if n is the number of elements in the list, big O for the linear search is n. And since binary search is to compare the target value to the middle element of the list, the big O is log n. To sum up, the binary search is faster than linear search, except for small lists. But the list must be sorted first. And here we can also test the summary through the code. Let's say if we have a list from 0 to 50, we can see the time spent for these two methods are almost the same. However, if we say we have from 0 to 100,000, and we want to find a target value in this list, and we just randomly pick a number, and we can see the binary search is much more faster than linear search. You can also test it by yourself. Okay, that's it for this video.